and welcome to my small little video tutorial here for the smart reliable power supply solution. And I want to show you a little bit how to get started with this solution. So I prepared a little hardware setup here for you with the Caparock system here in the center. I'm using the Profinet version, so the Caparock PMPN. Attached to it here I got I got the circuit breakers, the 1-channel, the 2-channel and the 4-channel version, and then I'm using a QuintPower 40 amp power supply. To retrieve the data I'm using a PLC Next technology PLC here, the HCF2152 from Phoenix Contact. This is where I'm using the library on. I'm programming this controller today together with you and for you to show you how to set this thing up. So let's go back into our PLC Next Engineer, and I've already prepared a small project here. The first thing you always want to do is set up your hardware. So I already integrated the controller, and I also did the Profinet setup here. So here you can see I integrated the Caparock PMPN Profinet device, and I did that over file import, and I used the GSDML file to put it into my device catalog, and you can find that here on the Caparock PMPN on the homepage here of the Caparock PMPN power module, and you will find it here under downloads, and then you can just integrate it under file import GSDML file, and then here under the Profinet let's see, device data list. No, that's not it. Online device list. Here, exactly, the device list. You will find here, if I type in Caparock PMPN, you will find it and can choose it from the device catalog. But I've done it already, so it's integrated. We can now go here into our Profinet device, and then we will see the different subslots that you can use with this device. So subslot 0 is always reserved for the PMPN device itself, and then you have subslot 1 until subslot 16 for your circuit breakers. So in total you can attach 16 circuit breakers in different version according to your needs to this system. So like I said, I'm using a 1-channel, 2-channel and a 4-channel version here, and I already attached them here and integrated them here in my Profinet setup. Then there's a subslot 17 that's always reserved for my QuintPower if I'm using it. So here you can also choose between the 20 amp version and the 40 amp version. In this case, I'm using the 40 amp version. Yeah, this is the hardware setup. Then we are done with this, and we can move over to the software part. In order to use the function blocks, you want to integrate the software library Caparock Basic, and you will find it in the PLC Next store, and just search for Caparock Basic and it will appear, and you can download it here under the download button. I've already done it and integrated it to my project, so you can see here up here that my function blocks that I can use already appear. So let's start right away with the first function block. I'm using the Caparock PMPN function block here, which is the function block for the head module PMPN. And let's put the variables on our input here. XEN is the bool variable for enabling this function block. And the good thing here is you can just double click on the input, then type your desired variable name like I did here, xen, I named it the same, and then you can right click on the variable, create new variable, local or whatever type of variable you want to create, and it will, in this case it's a local variable, so it will automatically create a variable here in the variable list, and also choose a the according variable type, according to your input. You can see it here in the AR in variable or input. Let's do the same here, create local variable, go in the variable list, it will automatically appear here, and also automatically choose your or the needed data type of this variable. So you don't have to go into the documentation or anything and see and look up the data type. You can just create one and will choose your data type. The ARIN is a byte. It's a byte array that we are getting from the Caparog PMPN head module, and we are feeding the function block with this raw data from the device, and we can see the data here at the end, the different variables. So we're just mapping the raw data to the output variables here in order to easily use our data that is provided by the device. Then we have another input byte here with the bin device state, and this is basically the data that we are analyzing to monitor the Profinet connection between or the Profinet status of the Caparog device. We can do the same here, create new variable, local, and it will automatically appear in the variable list. Then we have the BCFG. I'm just naming it the same way. It's a config byte, and this config byte, only the first bit is used right now in order to enable and disable write from the visualization. So we will see it in a different video, in a following video where I explain the use of the visualization. And you can enable and disable to write from the visualization. So for example, the different circuit breakers, you can enable and disable the channels. You can do it here over the function blocks. You have buttons here, physical buttons here on the devices where you can enable and disable the channels, and you can also do it later from the visualization. And because you don't always want to be able to do that, you can enable and disable it, according to whatever is needed. And that is done here over the config, or the first bit of the config byte. Then we have an input X global reset, and this is an input, a button that you can activate, and if this variable and this input is set to true, in a case of an error, for example, a short circuit or something of the circuit breakers, you can reset the whole system. That is always needed after an error. So yeah, this is the global reset input. And then here we have the SR Caparog global structure. It's a data structure that is used to exchange information between all those function blocks. Okay, here we have to create the variables again. And now, very important, we have to attach and connect the input process data variables to the hardware here, and we are doing it here in the hardware PMPN. we go into the data list, and here you can see you can move it over a little bit so you can see it better. Here you can already see the PN device state, and because we already attached, or we also already created the variables, you can not see the variables right now. So I know why, because we have to set the variables that we want to use as input data variables to device state external variables. So the usage is external and not local. The same with the RAR in. So going back to our data list here, now we can see that it automatically appears here, and only those with the right data type, the only variables with the right data type will appear here. So you can't you can't mix them or anything. The same here with the input data. So ARN, attach it to the variable, the process data item to the variable, and now we should be ready to go. Let's see. Let's save the project. We are connected to the controller, so can write and start the project. 0 errors, always good. So let's go and see the online view. Enable the function blocks, and here you can see here you can see that it's live. So we have no errors right now, so this is why they're all false. But you can see here the input voltage. We have no no devices connected to the circuit breakers here, so there's no current flowing at the moment. So this is why it's 0 amps right now, but you can see the 24 volts that device gets as an input voltage. So this is how easy it is to get the data from the devices or from the PMPN device. Let's move over and let's go on with the other function blocks. So now that we are getting the data from the Caparog PMPN head module, we also want to get them from the circuit breakers. So because we're using 1 channel, 2 channel, 4 channel circuit breakers here, so 3 circuit breakers, we have to use the Caparog E1 for the 1 channel, then the Caparog E2 for the 2 channel, and then finally the Caparog E4 for the 4 channel circuit breakers. So they all have different data types as input variables, input data. So this is why we split it up into different different function blocks here. Here we can also use, to make it easier, the same enable for all the function blocks, and then we are doing the same as for the PMPN function block. We are using the AR in, I'm calling it E1 here, as the input data byte. We can also create a new variable here because we needed to connect it to the process data item later. We can directly create an external variable here. We need to use a slot number. So because the subslot of the E1, I choose, you can see it here as well on the left side, I chose 1 as a slot number here, so we can call it 1 islot E1. And here it also attached the global variable structure SR Caparog. And here you can is an input or input-output variable for enabling and disabling the channel. In this case, it's only one of the E1 circuit breaker. So it's a XXCH1 E1. Okay. So now we also want to also created it. Here the slot number can be local, so local variable. Here this one also can be local. Okay. If you want for the slot number here, we can give it an init value. Let's say 1 because our one channel is at subslot 1. And go back to the code. And now we want to do the same basically with the E2 and E4, and also attach the connect the process data item. So we want to go here in the Caparog E1 data list, and here now in the Caparog in process data item, we can choose the AR in E1 input variable, and now we have to do the rest the same with the rest of the with the E2 and the E4 as well, because they are all the same function blocks. Now you can see I attach all the variables, and I also connected all the input variables to the process data items. This is for the Caparog E2, and this one is for the Caparog E4. And now we can download the project to the PLC. Let's go into the online view. Enable all the function blocks. You can see here there's no this is a function I wanted to show you guys as well. If there are two of the same slots for the circuit breakers, it will throw a slot error, because it's not allowed to have two circuit breakers attached to the same slot. I mean, it makes sense, but if you can see here, you have 2 zeros here, so let's put this to subslot 2. So this is ready now, and this one to subslot 3. It gets ready. The errors are not there anymore, and you can see here in the nominal current it will retrieve the data. There's no, like I said, no devices attached to this to the circuit breakers now, so we can't really see the live view, but we could go into our watch window. Let's go to watches, and let's see state info, because here this is a structure, the SRCH1 state info. The state info is a structure. We can add it to watches. It's what state info. And here we will see more data. You can see if I see this one is this is just for the channel 2, but I can also turn on the channel 1. This is for the E2. Like you can see, nothing happens. This is weird. I pressed I activated, enabled the first channel now of the Caparog E2. I know why it's not working. I forgot something very important, because those function blocks not only have input variables, they also have output variables. So let's go here, AR out E1. Also create an external variable, AR out E2. Create external. The same with E4. And also with the AR out PMPN. Create external. Create external. Now let's go into our Profinet settings here. E1. You can see the data list here. We not only have input data, we also have output data. And here we can choose, this is the E1, here the E2, and here the E4, and also the same with the PMPN head module. So it's download the project again. Go into our main homepage, our main page. Go into the live online view. Slot error because I don't have init values here, so we're using 2. We're using 3. So now it's ready. And yeah, you can see here that channel none is true, and I can now, because it's retrieving data, the devices are retrieving data from the function block again, I can also enable and disable the channels here over the function block. See, channel on is false. I can activate it again. It's true. And the same is possible over the device here. There's buttons, physical buttons on the devices. So if I press it, on, off. So yeah, this is it for the circuit breaker function blocks. And yeah, let's move on to the function block for the power supply. So yeah, let's instantiate the power supply function block here. It's basically the same procedure. It requires the SR Caparog, global structure, then an XEN activation variable. It also needs input data over the WIN here. Also external. And here we need the Profinet name, because we are getting we're not getting all the data over process data, so the power supply doesn't provide all the data as process data. A big part of the data we need to retrieve acyclically. So we need to request the data, and then it sends it over after a request. So we need the Profinet name of the Caparog device here. Let's see, settings. So product name, AML station, AML APC station name. This is what we need here as an input. So I'm just putting it as an input here. Let's see, I think I need to do it this way. So this is the Profinet name of the device that's requesting the data. Here an input to enable and disable the acyclic read. So if you don't need the acyclic data, you can just retrieve the process data, and you can deactivate the read acyclic read cycles cycle if you want to. Here's the delay time. So if you don't need or for the acyclic data, acyclic read, if you only need, let's say, the acyclic data every 30 minutes, you can type in a delay here, and then you will get the data every 30 minutes if it's okay with you. And here, this is IPS type. IPS type. So it's the type of the Quint power supply. So it's either 20 amps or 40 amps. The 1, if you type in, it's an integer value. So if it's 1, it's the 20 amps. If it's 2, it's the 40 amps. And I'm using that, or we are using that for displaying the right faceplate in the visualization, but we will come to that in the video for where I explain the visualization. So let's create the variables here, or our local variables, and that's it. This is all the data that are provided as structures here. I can show you later. Now we have to connect the process data items to the variable. Here we have the win. Right, and start the project. So let's go into our live online view. Enable the function blocks. Here we have a slot array again. It's put in the right slots. Yeah, and here we have the 2. It's not important right now, but here you can show it's put, for example, the process data to the watches, to the watch window, so you can see what's provided as data. Here you can see this is the process data that's provided. Input phase sequence 2, service live error, phase failure. So this is the system data that we are retrieving from the Quint power supply. And this is the acyclic data, for example. So this is process data, and all of the other structures are acyclic, are retrieved as acyclic data. It's, for example, use this, put it into the watch window. Right now we are not getting data because we haven't enabled the acyclic read. So it's enabled, and here you can see total operating time 28.9. This is the data that we are getting from the device. So this is the Caparog PS cap PS function block for the Quint power, and only one is missing, and that is the cap diag function block. So let's see how you can use the diagnostic function block, the cap diag. Same procedure as always. We need the global Caparog structure, and here as inputs we only need the enable to enable the function blocks, and this is basically it. I can always recommend to use it because it shows you all the errors in case there is any, it's provided as just one string output, so you can directly see and have everything in one view basically. So let's start the project. enable. Here's warning. You can already see, I can put it also here in the watch window. You can see here slot number are two identical slot numbers. So it detected it. So it's 2 here. And it's 3 for the E4. So you can see the COM-DIAC, there's no error anymore. But here we have a phase failure. It's not a phase failure because I have
If can show you my hardware structure here, I have not attached any input AC here, so this is what it detects. So if I would attach here an input AC, the arrow would go away. In case it's 3 phases, if it's 2 phases, this arrow would still
be live. So yeah, this is it. This is the Caparog basic library, and this is how you set up your smart reliable power supply solution easily. You can easily integrate it into your system. You don't have to program anything for yourself. You can just download this library, use it right away, set up the function blocks according to your hardware, and then yeah, start monitoring your power supply and yeah, get some reliability in your power supply.